All right, guys, two important rules for derivatives today is going to be product rules and quotient rules. Now, does that mean throw all your power rule and exponential rules out the window? No, because we need them to be able to be successful here. So today, question, how do you find the derivatives of both products and quotients, and how do you use shortcuts to find them, okay? We're going to look at these in a couple different contexts today, but product rule, my friends, the product rule is going to come up when we start having situations where we might have something like x squared times e to the x as our function.
Hey Carson, you gave us 2 sets for all of
Oh, well, you don't probably want 2 sets, do you? I mean, you could probably sell them and make a profit off of these. I mean, I just wrote these yesterday.
I don't think
Are you serious? Because this is like, really, this is like my handwriting, just the Microsoft Word. I mean, this is really my handwriting.
Premium paper.
Looking at a new one, too.
Yeah, exactly.
I was looking at a new one. Boy, the new ones are sweet. So, all right. So we're going to run into situations like this. Look at this right here. I have x squared times e to the x. Now, guys, we haven't talked about how do we find derivatives of stuff that's combined like this when we have like a power function and an exponential combined right here. Okay. So there are rules for this right here, guys. And we talk about product rule right here. The product rule right here says if I have a function f times a function g, so this x squared would be like my first function f, and this would be like my function g right here. The derivative of one function times another function, what's it say it's equal to? F prime times, or the derivative of f times what?
G
Plus f times the derivative of g. Now guys, whatever reason, and I don't know why they did this, okay? For whatever reason, mathematicians have said, well, we like the f and g stuff, but sometimes they like to substitute things, okay? And I'll be very honest with you, sometimes I do the same thing. Sometimes they don't use f and g, they'll use u times v right here, okay? So like what I would do is I would say, I would let u equal x squared. That's the same thing as this. This f and g is going to be the same thing as u and what here, kids? U and v, okay? It just, for whatever reason, they like to substitute u and v to be certain functions. It's kind of universal. Sometimes they'll have f and g, they might have an h or a j or something like this, but if I want the derivative of u times v, same thing. It would be u prime, the derivative of the first part times the second, plus the first part times the derivative of the second, okay? I'm just letting you know that these are really the same exact things. You might see them in a different notation, all right? Now, that said, you guys know what notation I like to use all the time?
X and Y.
I like to use, well, actually I'm going to use u and v, okay? And x and y, we want to use x and y for the functions that we're given here, okay? But I always like to say, let's let u equal x squared, and let's let v equal e to the x, okay? So I'm kind of substituting here, and I'll show you what that looks like when we get into some examples, okay? Same thing with the quotient rule. We might start seeing functions that look like this. I might have something like x squared divided by e to the x, and I ask myself the question, what's the derivative of that? And I said, well, I don't know. But isn't x squared a function in the numerator? Isn't e to the x a function in the denominator? Okay, so isn't that some kind of a quotient function there, kids? And I say, all right, if I'm dealing with a function f up top and a function g on the bottom, the derivative of it, here's the rule. It's the derivative of the top times the what? G would really be the bottom, right? Minus the top function times the derivative of the bottom over the bottom squared. Alternatively, if I'm going to substitute using u and v, let's see if you guys can write this for me. Anybody want to guess what u over v prime would equal?
U prime.
U prime times
V minus U times V prime over V squared.
Okay, now, I like this form, and I'll show you kind of how I work this here, but let's get rolling, okay? First rule we're going to implement is what, kids?
Quotient, or the product.
Product rule, okay? So what I like to do, guys, is this. I like to say in this right here. It says find f prime of x for the following. We're going to be using the product rule right here. And it says, kids, well, let's let f of x equal x to the fourth times what here?
E to the x.
So what I might do here, guys, is I might let u equal x to the fourth. Okay, what do you think we're going to let v equal then?
E to the x.
Okay, so I'd like then from then this here, then u prime, I can figure out what u prime is. Let's see, x to the fourth, is that a power or is that an exponential? That's power, so what's v prime going to equal? Or what's the derivative of x to the fourth going to equal?
4x to the third.
Okay, and then I know v, we set v to be equal to e to the x. What's that mean v prime would equal then, kids?
Natural log of e. Well,
So natural log of e being what value there, Ellie?
1. So
1
it's
times e to the x. So the derivative of e to the x is just itself, right?
Yeah.
E to the x. Okay? Now kids, let me show you why I don't like to use f and g. Okay? They're calling all of f what function here, kids?
That.
It wouldn't make sense to say, well, this is f of x, and let's see, let's call f just x to the fourth. The f in this case is called all of x to the fourth times e to the x, isn't it? And this is why I like to use u and v. U and v are very rarely used in functions, so they say, let's let u equal one part, and let's let v equal the other part, okay? Guys ready to go on to derivative? Lie to me and say yes. We're ready,
Yes.
Parson. Ooh, boy. Let's get a different color for f prime of x. Here we go. F prime of x. What rule am I using here, kids?
Power rule. Product.
Product rule. Okay?
Gosh.
Product rule says the derivative of u times v is u prime times what? Let's do that first part. U prime times v. So what is u prime over here, kids?
4x to the third.
So this is going to be 4x to the third times v,
E to the x.
e to the x, plus uv prime.
Plus
What is u?
E to the x. Oh, u. X
u
to
is
the fourth.
x to the fourth times what?
E to the x.
Okay. You get to that point right there, I'm going to be like, that is awesome. Good job. Okay. Now sometimes they might have an alternative way of writing that. If you look at both terms right there, they might factor some things out. Like, could I take an x to the third out of both of these? Could I take x to the third out of both of these?
Yeah.
Could I take e to the x out of both of these?
Yes.
I think if you get to this part right here, leave it, okay? The way you might see it, and I'm not sure on this, I might have to check, but if I take x to the third, e to the x out, what would be left if I took x to the third, e to the x out here, guys? Would it just be 4? You might also see it written that way. They may factor it, okay? I think for you guys, for now, should we just go with the first one? Okay, but do you get why what I wrote below that is equal to this? I could factor an x cubed and an e to the x out of both in my final answer. And then the part that's in parentheses of what would remain in both parts, or both terms, after I factored them out. So if I took 4 times this mess right here, wouldn't that make this part? If I took x times this mess out front here, wouldn't it make that part? Let's try another one. I love this stuff. I'm going to kind of sit back and hear what you have to say about this. Okay? Guys, notice in the second one, on the right side, aren't there some parentheses involved in this?
Yeah.
Okay, so the parentheses, that whole set of parentheses is going to be like my u right there. Okay, so what are we allowing u to equal here in this one? I guess maybe I should back up. Do you understand why this is a product?
Yeah.
I see some addition going on right here. But we're going to treat this first part as like my u value here, okay? So let's let u equal what here, friends?
9x to the fourth plus 3 to the x.
So 9x to the fourth plus what?
3 to the x.
good with that? Okay, then, ooh boy. So from this, what would u prime equal?
36 x to the third.
Everybody understand 36x to the third here? Plus, okay, this is where I get worried.
The natural log of 3 times 3 to the x.
Natural log of 3 times 3 to the x, right? Okay, that's an exponential, right? And that's what we learned in the last section.
Yeah.
You guys with me on that? So what do you guys want v to equal? Ooh, I love it when we let v equal e to the x.
Yep.
Because what's that mean about v prime?
Equals e to the x.
You guys all picking up what I'm putting down? Okay, here we go on derivative. Okay, what's the product rule derivative? Or what's the form, or I should say, what's the formula, maybe?
U prime times v plus u times v prime.
U prime times v, so here we go on f prime of x. F prime of x is gonna be the following. I'm gonna write as small as I can for it to fit here. Okay, what's u prime, friends?
36 x to the third plus the natural log of 3 times 3 to the x.
I'm gonna put that in parentheses. It's gonna be 36x to the third plus the natural log of 3 times 3 to the x times v, which is what?
E to the x.
There's that part, plus uv prime.
So be 9x to the fourth plus 3x.
And what should I do with that 9x to the fourth plus 3 to the x?
Multiply it by e to the x.
Okay, I probably wanna make sure I put that addition in what?
Parentheses.
Yeah, this is my u right here. There it is, okay? Now guys, I could make you factor stuff out. I'm not gonna do that this time, okay? You get that far. I mean, I'm pretty sure if you took that home to your parents would look at you and be like, dude, what the heck is that? Right or wrong? Okay? Does it help you to write u and v down and then do u prime and v prime?
Yeah.
Okay, I think that's the best way to go about it. Sometimes teachers will just say, okay, start with u prime, and kids will write it, without writing it out first, they'll just say, okay, and then they lose sight of where they're at. I think it's good to write them all out and then put them together in the end. Does that make sense to everyone? Okay, now guys, this example says we're using which rule?
Quotient.
Example 1 says we're using product rule, right?
Example 1.
Now take a look at this third one right here, right? This third one in example 1. Kids, I have a concern.
We have used product rule?
Well, his title said to use product rule, right? What could I use here? Because it's written like a fraction, right? But the implication here is to say, I'd kind of like you to use product rule. So the idea here is that if you have a quotient, and they're telling you to use product rule, it might be a situation where you have to take the original problem and potentially rewrite it. So my question, kids, is this. What could I do with the x squared to make this a product?
4 times x to the negative 6.
So we could write this as x to the negative 2 up top, right? So do you all agree that I could write this as f of x equals 4 to the x times what, kids? X to the negative 2. Okay? All right. Let's try this one. Okay, so what do you want u to equal?
U is going to equal 4x.
4 to the,
Or 4 to the x.
yep. So what's that mean about u prime then?
Natural log of 4 times 4 to the
You
x.
guys got this. You guys are naturals at this. Just like the logs. Okay, that was enough. Never mind. Natural log of 4 times 4 to the x, right? What are you going to allow v to be then, kids?
X to the negative 7.
X to the negative 2. All right, be careful on your your derivative here,
Negative 2x to the negative third.
negative 2x to the negative third. Once your u and v are established, and u prime and v prime are established, is this pretty easy?
Yeah.
Okay, talk me through, friends. U prime first.
The natural log of 4 times 4 to the x.
Okay, so let me catch up. F prime of x will become u prime, you said, was the natural log of 4
You probably want to put that in parentheses.
times 4 to the x, right?
Mm-hmm.
Times v, which is,
X to the negative 2.
are you with me on that, guys?
Mm-hmm.
That's u prime times v, and then to that plus uv prime,
4 to the
so
x
4 to the x.
times negative 2x to the negative 3.
Okay, now I might rewrite this one just to make sure we're good on this. Guys, where could I move that x to the negative 2 to now? I can move it to the bottom, couldn't I? And make that a positive exponent in the bottom now, right? So your finalized answer is probably going to look like this, I think. You're probably going to have f prime of x equal natural log of 4 times 4 to the x over what? X to the second. You guys all okay on that part? That first set of parentheses plus. Okay, guys, be very careful on this. Kids do this all the time. So many times people want to take this negative 2 times the 4, but I can't do that because this is 4 to the what?
4 to the x.
This is saying this is 4 to the x. It's not negative 8 to the x. I can't put that together. Okay, so this is the same as negative 2 times 4 to the x. Okay, where's that x to the negative 3 going to go? It's probably what it's going to look like when you start looking things up there, okay? All right, I want you guys to try one on your own, see how it goes here. Product rule, so see what you can do with that next one. Maybe you're hinting this one. Do you see that cube root of x?
X to the 1/3.
Maybe call that x to the 1/3, okay? See what you can get on a derivative there. Take about a couple of minutes, 2 minutes or so. Once you've got an answer, maybe check with somebody. Again, I'm worried about the rule right now. We'll worry about the simplification when it starts to matter a little more, but I'm just worried about the product rule right now. So see what you can do to see if you can obtain a derivative here. Guys, every time I go to Walmart, it never fails. And I don't like to go there often, trust me. If I can avoid the place, I avoid it. But if I have to go and use a cart there, it never fails. I've always got a cart with a tab wheel, every single time. And I'm afraid to touch it. I do it. Alright, what'd you guys allow u to equal here?
X to the 1/3.
X to the 1/3 power, very good. What's that make u prime then?
1/3 x to the negative 2/3.
So it'll be 1/3 x, pull that power out front. X, let's see, 1/3 minus 1 would be an exponent of negative 2/3. Give me a show of hands, how many agree on u and u prime right now? Okay, how about v? What do we allow v to equal then? 3 to the x. Okay, this is exponential, so by rule, what's v prime have to be?
Natural log of 3 times 3 x.
Okay, so if you've established this right here, my friends, if you've established that part right there, is the product rule going to be easy?
Yeah.
Okay, so let's roll. Let's go with u prime first, which is what?
1/3 x times, yeah, 1/3 x to the negative 2/3.
Okay, now I might, are you guys okay if I start working with that in terms of radicals again?
Yeah.
If I call this, that x is going to move to the bottom since the exponent's negative, right? So is it okay if I call this 1 over, okay, 3, help me out here, kids. What index would you have here? What root really is? Cube root, right? X to the what? Guys agree with that? The x to the negative 2/3 would be x to the 2/3 in the denominator along with the 3, right? And then x to the 2/3 is like the cube root of x, and 3 being your index, and then that 2 up there in the numerator portion of the exponent would be the exponent for x, right? Okay, you guys agree with that first part? Yep. So there's u prime times what, kids?
3 to the x.
Now, if I wanted to, could I put that 3 to the x up top here?
Yeah.
I could. Okay. I'm going to leave it that way for now. Plus uv prime. Let's see that x to the 1/3 for u. Could I write that as cube root of x again? Times what?
Times the natural log of 3 times 3 to the x.
Oh my gosh, you guys, look at this. Isn't this just beautiful?
That's horrendous.
Oh my gosh, I'm serious. That is pretty. Why am I the only one smiling right now?
Painful.
You guys are smiling at me like, Carson, you're weird. True that? Bell's shaking her head. Yes, I love it. She's right. Okay. Questions on the front side. How we feel about product rule? Are we okay with it so far? Yeah, no? Pretty good? Okay. If I had to say u times v is my function, what's the derivative? What would you spout out? U times v is my function. What's its derivative? U prime v plus uv prime. Very good. I love it. Okay, everybody have what they need right here? Questions about that? I just want to do a quick formative check. Give me a show of hands. How many are at least kind of on board with me right now? Okay. You might be hanging on by a thread with the train running down the tracks about 100 miles an hour, but at least you're still hanging on, right? Okay, let's go try another one. Okay. Now guys, the idea is going to be the same exact thing here for quotient rule. We're going to look at some quotients. But again, if you can identify u and v and their derivatives respectively, this should be pretty easy. Okay. So here, I'm just going to write this down. Suppose I have a function where u is divided by v. Okay. The derivative of that, I'll just jot it down so we can look at it again up here, is going to be u prime times v minus uv prime all over v to the second power. Okay. I typically let u be the numerator. That's the way it's written up there. And then v is going to be the denominator. So guys, you know what? This is a little easier actually than product rule because it's pretty set in stone what's what here. Top is u, bottom is what? Okay, here we go. So for this derivative right here, u is going to equal what?
2x plus 4.
So by rule, u prime would be equal to
Just be 2x.
just be Well, we use power
Two-
rule on it.
2x.
Just be 2, wouldn't it? Because the derivative of 2x is just what?
2.
And the derivative of 4, a constant, is nothing. You guys agree u prime is 2?
Yes.
What do you want v to equal?
2 to the x.
So that implies that v prime shall be
Natural log of 2
Yep.
times 2 to the x.
natural log of 2 times 2 to the x. Okay, my friends, here comes f prime of x. So f prime of x would be u prime first, right here.
2.
Okay, so it's going to be 2 times,
The natural log of 2 times 2 to the x.
careful, it's u prime, which is 2, right?
Oh, so
Times v, right?
2 to the x.
2 times 2 to the x to start. We all agree there? And then we're going to have, whoops, not plus, but what now?
Minus
I almost got caught there. Okay, so the next one I want is u, which is
2. Or, gosh, 2 to the x plus 4.
2x plus 4, right?
Yeah.
And I'm going to leave that in parentheses. That's my u function. Times v prime, which is what?
Natural log of 2 times 2 to the x.
Natural log of 2. I'm going to spill over a little bit. You guys try not to. Okay, that's my u prime times v right here. Minus u v prime right there. What's this all over, kids?
V squared.
2 to the x, all to what power? Okay? Now, if I wanted to, I could call that 2 to the 2x power if I wanted to down there. I could bring this exponent into this exponent and call it 2 to the 2x, but I don't know. I still, look, I don't necessarily need to write these down. I could just look at the formula and just start writing, but it helps me to write these down and then piece them together, okay? Should we try another one? They want to try, they're pretty excited over there. Somebody win the lottery? They sound like the lottery dude. Woohoo! All right, rock this. Here we go. I'm done talking. You tell me what to assign.
6 plus x
6 plus x squared.
would just be 2x.
Yep. What are you going to assign v? Root of x. Is it okay if I call it x to the half so we can differentiate easily?
X to the 1 half, so it would be 1 half x to the negative half.
Okay. Let me ask you this question. I know I'm giving you 2 new rules, but once you've figured out what the parts are we really doing anything differently? We're just taking what we know already and piecing it together in these formulas now, aren't we? That's all we're doing. Okay? And I told you, if I had to tell you, there's, I don't know, some things in calc that I think are super important. Some people may disagree, but I think if you can't do this, product rule, quotient rule, we're in big trouble. Well, you're proving to me that we've already got the background for this to make this pretty easy. And if I think this is pretty important, you should be successful moving forward, okay? All right, here we go with f prime of x. F prime of x. U prime times v.
2x times x to the 1 half.
Is it okay if I call that 2x times, can I change that x to the 1 half back to root x?
Yeah.
You guys okay with that? What in the world? I don't think they're from this planet.
Minus 6 plus x squared.
Minus 6 plus x squared. I'm going to put that in parentheses as all of my u, okay? Times v prime. Now this v prime, kids, that x to the negative 1 half, that negative 1 half can become positive in the numerator or denominator? Denominator. And x to the 1 half is just like the,
It would just be x over 2.
well, isn't this like the square root? If I put this down at the bottom, this would become positive, right?
Yeah, so you
And
just
then-
need square root of
So I'm gonna call this 1 over 2 root x. Right there, for my b prime. Oops, I forgot to put the little prime sign up here, didn't I? Make sure you guys got that. If you missed that, I forgot that little prime sign. Then this is all over what, kids?
half x to the second.
If I take x to the half, which is the square root of x, and square it,
Or to the negative second. Wait.
it would just be what, right? X, wouldn't it? X to the 1/2 all squared. What's 1/2 times 2? 1, so it would just be x to the first down here, wouldn't it? All right, guys. I'm gonna have you try these next two on your own. See what you can do here, okay? These actually are a little easier than the first two that we did, so see what you can come up with. Okay? Maybe I'll have some people go to the board and do one. Hell, you wanna do one? Don't put you on the spot. Gator?
I'm alright.
Gibby?
My handwriting is.
Okay, you got it. I get it. I get it.
I can tell you what to write.
Okay, all right. That's
I'm not
awesome.
saying it'll be right, but.
That's okay.
Hey, say, help. I can't tell by using decent words.
Okay, I can tell.
They're so similar.
Oh my god.
Guys, they clearly have more fun than we
I
do.
believe that.
Apparently.
Don't tell me those don't look
Want to
kind
be
of
like them.
Yeah, I see.
What time's this end again? I've totally, is it 10:07?
I think
09? Sorry.
What are you doing?
I was gonna throw a ball. Plant, rotate, and push. But you don't want your arm coming up here, you want it going over the.
That's great form. I said he's basically Luke Bryan. That's not a baseball player at all. Who am I thinking? Oh, Chris Bryan. But I said Luke Bryan instead.
I can start giving out 3 pitches. That I can probably strike him out on 2.
He's like all the way.
He swing twice on my pitches. All right, let's try this first one, kids. This first one I think is fairly easy. Let's hear somebody other than Ellie here.
I got you.
Okay, go, Gibby.
Alright, so the U is ln 22. Oh, just normal and just 22x.
22 to the x, right? So what's that make you prime, buddy?
Natural log.
Yep.
22
Yep.
times 22x.
Times 22 to the x, very good. How many agree on the u and u prime? Okay, anybody messes up v and v prime on this, I'll be upset. Go, Gibby, don't mess this up.
It's just e to the x.
Both of them, right?
Yeah.
All right, so let's talk about derivative using quotient rule here. What have you got for f prime of x, friends? Gibby, you want to pass it off or you want to stay with it?
Oh, yeah, I got it.
I'm rolling.
Natural log 22 times 22 to the x. And then times dx
Times e to the x.
minus 22x times e to the x.
22 to the x. Times e to the x.
And then all over the x squared.
Give me a show of hands. How many of you think Nate has done that correctly? Okay, how many had that?
Yeah, how about that?
Very good. Very good. Okay. All right, let's try this last one, and I think you guys are understanding. I feel pretty good about this. I'll run through this real quickly. Shout it out. What's u? 3t squared. So that makes u prime. You tell me if I'm right or wrong. Is that 6t? Don't write down 60. Write 6t. Some people will write 60. Okay? I told you to go up about 10 plus 10, right? Same as 11 plus 11. Have you heard this one? Did you guys know that 10 plus 10 is the same as 11 plus 11? Because 10 plus 10 is 20. And 11 plus 11 is 22.
That's a good one.
Okay, bad joke, let's move. What's B prime, my friends?
B prime,
Yep.
35t to the 6 plus 7.
You guys are really good at this right now. I love it. Okay, anybody want to shout out the final answer here then? This might show up on your $1 million question. You won't even need to phone your teacher.
6t.
Okay, so it'll be 6t.
Yeah, I don't know. You never said so.
5t to the 7 plus 7t
5 to the 7th plus 7t, right?
minus 3t squared. Squared times 35t to the 6 plus 7.
Oops, I forgot something. 35t to the 6, right?
Yeah.
Come on, Buster.
I know. I'm getting slow in my old age. I'm losing it a little bit here and there.
All over 5t plus, or 5t to the 7 plus 7t squared.
That whole quantity squared, right?
Yep. So could you do like 5t to the 14th plus 7t squared?
Well, you'd be very careful on that. That would be like a FOIL thing. You would see that expression times itself.
Oh, gotcha.
Okay, so you're not really doing
But
the
you
double there.
But you don't have to FOIL that, you can
You don't, and that was a point I was gonna bring up, and some of the things, like, you look at these messes right here that we have in the first three, and you're like, I found it, I'm done, pretty much, right? Now, it's something like this, when everything's like a polynomial here, could I distribute these two to get something here? Could I distribute these two to get something here and see if some things would simplify better for us? And then could I take this quantity down here and square it? I could do that with those, okay? But for now, let's just leave it as it is right there, okay? All right, guys, my main concern, product rule, quotient rule. Are we so far so good? All right, let's try an application here. I think I'm gonna make this my last problem of the day, and we'll finish up the last two tomorrow. Is that okay? So Grant and Nate, if you guys are gone tomorrow, anybody jump online. What's that?
We gone next week, though.
Okay. Okay, I like this problem a lot, guys. It says, suppose f and g are differentiable functions with values shown in the following table. It says, for each of the following functions, h, find what? H prime of,
H prime.
okay. So guys, it says h of x is equal to f of x plus g of x, right? Okay, so down here in this table, they give you a table. They say that when x is what value? 2. That's important because we're looking for h prime of what here? 2. Okay, they say when x is 2, what's f of 2? What's g of 2? What's f prime of 2? And what's g prime of negative 2? Okay, in part A, kids, they're asking us to find h prime of 2. But my friends, I'm going to put some work down here for A. If h of x is equal to f of x plus g of x, guys, this is just the sum rule right here. What would h prime of x equal here? Wouldn't that just be, it's not a product and it's not a quotient. This is just stuff added together. So wouldn't that just be f prime plus g prime?
This would just be 3 plus 4.
So this would be f prime of x plus g prime of x, right? Okay, so in part A, what is f prime of x, kids? Or in our case, f prime of what is the x value here again? What's the x value over here again that we're worried about?
2.
Okay, so we'd really be plugging 2 into this right here. So for part A, it's really going to be, we said h prime of 2 would be f prime of 2 plus g prime of 2. What's f prime of 2?
5.
What's g prime of 2? So this would just be 5 plus negative 2, wouldn't it? Which is what value?
3.
Okay, it has to be 3. Okay? That's it. Okay, now part B, a little more difficult, because part B, this is saying take f of x times what? G of x, okay? So in part B, let's write a rule for h prime of x. My friends, h prime of x would be, okay, f times g, isn't that a product? If I treat f of x like u and g of x like g, my derivative would be f prime of x times g of x plus f of x times g prime of x. So numerically speaking, in part B, let's plug our values in. What's the f prime of 2?
That's 5.
5, so this is going to be equal to 5 times just g of 2.
4
5 times 4 plus,
plus 3 times negative 2.
so f of x would be 3 here. F of x is 3 times g prime of x, which is negative 2. Boy, I'm not very good at math, but I think that this is 20 plus negative 6. Is that right?
Yeah.
What do we get in the end? 14. Okay. My question, kids, is this. Given that table right there, do you understand the product rule? If h of x is equal to f of x times g of x, then h prime of x, you'd have to use the product rule there for those, right? What do you think we're going to use in part C? Quotient rule. Should we try and cheat the quotient rule? Yeah, I think we know the rule, right? Derivative of the first times the second minus the first times the derivative of the second all over the second squared. Okay? Let's treat it like this. Let's treat this like u over v. So by rule, the first one would be f prime of x, wouldn't it? Or u prime?
Yeah.
What is f prime of x? It's going to be u prime times v, which is 5 times what? Minus uv prime, or in this case, fg prime.
3 minus 3 times negative 2.
So 3 times negative 2 all over v squared, or in our case, denominator squared, which would be g squared, or 4 squared. Okay? I know I'm going quickly, but do you guys understand the values I just plugged in there? That'd be like the u prime v. And it makes kind of sense here, because guys, look up here. Wasn't this u prime times v up here for product rule? Same way in the quotient rule starts u prime times v. Here's a plus, but in the quotient rule it's a minus uv prime. Same values here. Guys, help me. What do we get up top here? 26, is that right? Because this would be 20 minus negative 6, right? So this would be 26 over what?
Would you do 16?
4 squared would be 16, yep. 26 over 16, now if I want to reduce that 13 over 8, is that okay? Or I could call it 1 and 5/8, however you want that to look. My concern, not so much the numerical value, is did you get the numerical value using the process right there? Okay. Product rule, quotient rule, you feel feeling good about them? Okay, we'll pick up the last 2 examples tomorrow. I'm going to stop there. Guys, do you want the assignment to start on now, or do you want me to hold off?